smartboard wasn't working on it.
Yes.
Okay, I got some brain eyeball stuff for you. Look at, I updated this.
Left and right. Wow.
Part of that is for me because it's backward and I'm not very good at my left and right to begin with, and I'm backward, I really can't do it. Okay, so equilibrium, we're going to say when the levels are equal, it's at equilibrium. Equilibrium really means that the reverse and the forward reaction happen at the same rate, right? The left side is the reactant side. We call that A and B, just for pretend. The right, thank you. The right side is, I really can't do it.
Just said left.
I know, but I look at this and it's my left, and there's like 75 steps that have to happen in my brain to make it. Like I have to like turn my body around, and it's.
Or you could just say, "Oh, this is left."
That's why I wrote right, so I could just read it. I just didn't ink it good. That's like teaching trick. So this is C and D. These are the products. Okay. We are gonna. The real words are. Thank you. The real words are shift left and shift right. Oh, see, okay, good.
I mix them up.
Okay, so now what? I thought you did. If we have the forward reaction, that means A and B is turning into C and D. We would call that shift right. Okay? If we have the reverse reaction, C and D is turning back into A and B, we would call that shift left. Shift just means that more is going to the other side. All right, so today we're going to play a game. If we are at equilibrium already, and let's say I add more products or reactants in, so I just pour a bunch more in there. What's going to happen is K cannot change. So that means that the forward reaction is going to happen until it reestablishes equilibrium. And we would say it's a shift, thank you. That's going to be a shift right, the forward reaction. Okay? Now watch. What if instead of adding more reactants, I take a bunch away? So then the reverse reaction is going to happen so that K stays the same. And to right, we would say shift left, and we would say the reverse reaction. I can do the same thing for the products, or not. What if I added a bunch more products and I just dumped them into the reaction beaker? What way would it shift, and is that the forward or the reverse reaction? It would be a left reverse reaction till it was back to normal. Now I can, this is what the Haber process does. And a lot of like actual industry stuff is they keep forcing the reaction by just removing the reactants. They have a process that just keeps removing it. If I remove reactants, what way is it going to shift? Is it forward or reverse?
Forward.
Forward, which is shift.
Right.
Right. To make more products, okay, stays the same. All right. That's called LeChatelier's principle. I can do it with concentrations and with ATMs.
Your smart board.
My smart board is.
Don't you have to rub the back?
It's one of the original smart boards in the building, so it's really.
How do you rub the back? Does that give you static electricity?
It builds static electricity back there on the brackets because they're metal brackets.
But then don't you shock yourself?
Yeah, you have to like.
That's scary.
Okay, draw a graph. And this is where we're going to need colors.
Hope is my favorite word.
I know that's not balanced. I'm not too worried about it. I know.
That's what 8.3.
Is that a T or an X? Time. All of our graphs are times.
Easily. 2.
That's all I knew was.
That's good.
You're cool, Sean.
This graph is here in this graph. Like not the beginning, not where things are turning into each other, but like after it's already at equilibrium, when like the two beakers are even. Okay? It's a Haber process. If at whatever time this is, I add in a bunch more N2, some nitrogen gas, my graph is going to spike up there. If I add in a bunch more N2, which way is it going to shift, right or left? Right, forward reaction to get back to even.
Why is it blue?
Color dye.
Because that's the dye pulled out of the drawer.
Why did you dye it?
Why does it matter? Okay,
Why did you dye it?
if I increase my nitrogen, it's going to shift right, and my ammonia is going to be made. It's not going to spike up. It's going to be like a slow gradual, like it's going to be made over time. They got to collide. They have to collide in the right orientation. They have to collide with enough energy to overcome activation energy, right? That takes time. In order to make NH3, I'm going to have to take some of my new nitrogen and react it with some of my hydrogen. So my hydrogen and nitrogen is going to go down. When it all evens out again, then I'm back to equilibrium. All of those amounts change to make K back to being the same thing. If K is 10, A and B and C all still have to divide out to be 10. Okay? I can do this with pressure. I can increase or decrease concentration on the reactants or products. And I could also increase or decrease pressure on reactants or products. There's a trick question that is adding inert gas and adding a solid and liquid. It would have no effect. Because, I'll tell you. A solid and liquid, no effect. Alpha, A, or E, okay? No effect like that? Okay. They would have no effect because those don't go into equilibrium. Remember that was number one on the quiz yesterday.
Yeah, you're almost sitting down.
Inert gases are things that are not in the balanced equation. So I said, what if I added a bunch of neon gas to this? Well, nothing. It's not part of the reaction. Okay? But now let's talk about temperature. Temperature is the only thing that can change K. Everything else changes so that K stays the same. Temperature will affect K. Because I'm going to shift the equilibrium. Remember we have this.
Really?
Remember K is our products over our reactants. The way I think I math this is how I do it in my head. I think it's the easiest way to do it. If we increase our C and D, that's going to make our numerator bigger. If I increase my C and D, my numerator is bigger. Is K going to be bigger or smaller?
Bigger.
If I increase my A and B, though, instead I increase my denominator, my K is going to go down because the bigger denominator makes a smaller K. How do you know whether you're increasing C and D or increasing A and B? Is you have to know if it's exothermic or endothermic. So let's do endothermic first. Endothermic is a positive delta H. Heat is going into the system, which means heat is like a reactant. If heat goes into the system, heat is like a reactant. That says heat plus AA. It's helpful to use context clues. We can't say it's an actual reactant because it's not a thing. It's just energy, but it forces the equilibrium to move. So now watch. If I add in that, if I add heat to an endothermic reaction,
It's dripping.
the equilibrium is going to shift back to the right, but I didn't add any more stuff, so that's why K changes. So if I increase my heat, and heat's a reactant, that means my C and my D are going to go up. If my C and D go up, my numerator goes up, my K is going to go up.
Increasing Kelvin.
Okay, now you talk with your battle buddy. What if I decrease my heat in an endothermic reaction? What's going to happen to my K? Ready, go. Which way? How does it affect K? Okay. Before people were in here.
Yeah.
Okay, we'll do one Hamilton. What do you want?
You'll be back.
Non-stop. You'll be back is way better than like one person. It's really hard to like with the actor. Yeah, it's that one. Have you seen it, Matthew?
I've not seen it, Charlie.
I don't want this.
I feel like that should be our field trip since our project is going to be making an ensemble. Okay, so if I decrease my temperature, my heat is on my reactant side. If I decrease my temperature, my equilibrium is going to shift. Reversed. So now my A and my B go up. My A and my B are the denominator, so my K is going to go down. What about exothermic, though?
It's the opposite.
It's going to be all backward. Exothermic is a negative delta H. Heat is like a product because it's leaving the system. If I increase my heat in an exothermic, is it going to go left or right? If I increase something over here, right, it has to go left. Coldies, the cards are actually super helpful.
You're welcome.
So A and B is going to go up. If A and B goes up, what happens to K? It's on the denominator, so bigger number on bottom. What if I decrease my heat, though? Which way is it going to go, left or right? My C and D go up. My C and D go up. My K is going to go up because it's in the numerator. Because my light bulb is so cool. Yeah, it's been doing that like for a few weeks.
And it went blue. The entire screen went blue.
Yeah, that was funny. Except that's not
Did it go red?
that's not because that was
It was because it was on fire.
yeah.
I didn't know they were
Catalyst.
It's like
Effect or affect?
Effect.
It's only effect if it's
Effect is
the
the verb.
subject of the sentence.
not the subject.
So it's, no, the direct object is effect. If it's subject, it's
Trick question. They will give you like, and a catalyst is added. How does it affect K? It does not affect K. It just makes it get to K faster, right? The words a catalyst speeds up the reaction by lowering the activation energy by replacing the slow step with a series of faster steps. It just makes it get there faster. Yeah.
You have to ask every class if it's an effect or effect.
I couldn't use my smartboard up until now, so I was just writing it.
Oh,
No, because did I write wrong there?
Yeah,
Oh.
no, it's wrong.
No, that's right.
Effect is a verb, effect is not.
I'm sure. Okay, 17. We're going to do sample problem 17.
17, 38.
Wait, what number?
17.
38.
Okay, Hamilton's going to sing to you. You do 17 with your battle buddy. Ready? Go.
Hamilton.
No,
Ed Sheeran.
Which part?
You didn't answer the question there. Which was information about it?
Yeah. Letter C. When we increase and decrease the volume, it's going to shift to the side that's either bigger or smaller. So if I increase the volume, it's going to shift to the bigger side, more moles. 6 plus 4 is 10 moles on the product side. If I would decrease the volume of the container, all the pressures are going to go up, right? Because it just got really squished. But it's going to shift to the side with a smaller amount of moles. 4 plus 5 is 9. And then this is the trick question also. You have a chart in the back of your worksheet, but let me talk to you about it. Because if I removed it, got it?
Wait, so because the volume went up, it went
To the bigger side. All the pressures would go down, but it would go up. Okay, this is just an infographic on everything that we talked about in case my brain eyeballs don't make sense to you. This green sheet is your lab for tomorrow. You don't have to do anything. There's no prep for it.
lab tomorrow.
There's no prep for it. It's just going to be in stations. You need to go around in groups of like all you guys. There's 5 stations.
So groups of the entire class.
Groups of like 3 or 4 like usual. We are done learning, so that means we are going to have a quiz on Monday. Today is Wednesday, tomorrow lab, Friday work day. You have your Form B due Friday, and
Wait,
quiz
what's all on
is
Friday? Just Form B?
So no video for the lab tomorrow? No prep for the lab tomorrow. What you're doing now is, in your worksheet packet, there's a big turning chart of this. You just get out your worksheet packet, get out your worksheet.
What? What else? Form B. What else? Work day. I think we're doing work. Almost. Why? What is that thing with the liquid in it?
Who's got pen?
No,
I do. Someone has the same pencil.
That's
I don't know my hand. Okay, the back page of your worksheet packet is big turning chart. The back, as my baby say when I do things, it's magic. The back page of your worksheet packet, just get it out.
what kind of gas?
I've got it.
Well, it's liquid.
But there's gotta be some gas.
No, it's the brush right. And my hands are
My hands are really.
this is work.
So if you warm it up, it's gonna go up.
Yeah, but why?
Oh my god. Both hands are steaming.